Today we'll get into multi-threading. This is one more challenging subject which developers face in developing applications. Okay, all developers face a big challenge when it comes to multi-threading. So multi-threading is a concept, and we have to see how that support has been given to you in Java. So parallelly you will be learning two things. One side you will be learning the multi-threading concept, and other side you will be learning what? How to do multi-threading in Java. So your problem right now where it stands is you don't know multi-threading concepts only. So that is your problem right now, where you stand. Okay. So one side you have to understand the concept, and that concept you have to implement it using Java. So again, for doing multi-threading you have got what here? Support from library. So you got the support, you don't have to worry about it. But first you have to understand the concept of multi-threading. Understood? So it's a new subject, so obviously you'll find it a little confusing initially, and later on you can get a better hold on to it. But to understand multi-threading, we have to understand one word here called as multitasking. We have to actually understand the word called as multitasking. So we have started multi-threading now. But to understand multi-threading, we have to understand what is multitasking. What is multitasking? I'll just give you an introduction now. What is multitasking? The name itself tells, and you are also very good engineers, you know how to spell it, define it now. Doing multiple tasks at the same time is called what? Multitasking. When you do multiple tasks at the same time is called as multitasking. Means concurrently you'll be doing. Okay. So say this many tasks can be done by computer also. Okay, we'll come to computers later, but first we'll see from real world point of view what is multitasking. See, we human beings, okay, we have the ability to do multiple tasks at the same time. Yes or no? Like you can talk on the phone, you can work on the computer, and at the same time you can have what? A cup of coffee. So parallelly you are doing what? 3 tasks. Okay, one is you are having coffee, second one is you are talking on the phone, third one is you are using the computer also. 3 tasks you are doing. But the thing is, even though you are doing 3 tasks at a time, okay, your human brain is actually called as the processor here. Your human brain is called as the processor. It decides to which task to give the higher priority. Okay, it will decide to which task to give the higher priority. But you might be doing 3 tasks at the same time. Okay, it looks like you are doing 3 tasks at the same time, but actually it is not. Okay, you will be concentrating on only one task. Okay, and other 2 tasks will be not done properly. Understood? Means concentration is given to only a single task, and that depends on you. You will give the priority to which task, whether you give the priority to the computer or to the phone or to your coffee. Understood? So it gives, that is where you have to decide. So depending on that priority, the switching will happen. Means your brain will start paying more attention to it. So same way in machines also, it can also do what? Multitasks. It can do multitasks. Okay. Like example is, let's see now. So in your machine also. So here the machine is nothing but what? Computer processor. There you got the CPU. The CPU is the processor now. It can also do what? Multiple tasks at the same time. So let's go in detail now. So when it comes to multitasking in machines or in computers, there are 2 types of multitasking. In computers, there are 2 types of multitasking. One is process-based multitasking, or we call the process as what? Sometimes program-based multitasking. Both are same. Process-based multitasking or program-based multitasking. Okay. See here in process-based multitasking, the minimum execution is on process or program. Minimum execution is on process or program. Like you'll be running Word. Okay, you'll be running a media player. Okay, and at the same time you'll be doing what? Browsing. An internet browser you'll be opening. So you're doing 3 tasks at the same time. Okay, so that is called as process-based multitasking, and here minimum execution is what? One process or a program. And this in fact is also known as, you know what? Also known as, okay, can you guess what it is? Multi-processing. It is also known as multi-processing. This is very important now. So what is multi-processing? Doing multiple processes or having running multiple processes at the same time is called as multiprocessing. And this is related to operating system. Means it is related to OS. And who will take care of this? Operating system people will take care of this. When they are designing the operating system now, they will take care, like how to handle so many process or program at the same time. Okay, they will take care of that. So it's not, so here, this is not our thing now, because we are not writing operating systems. We are writing what? Applications. So our focus will not be what? Multi-processing. We will not be discussing more about multi-processing. Okay. So anyway, this is about process-based multitasking. Now, again one more is there, called as what, you know? Thread-based multitasking. Now, what is thread now? Can you understand? It is a part of an application or a program. It's a part of a program or a process or application. It's a small part of a program or a process or application. First you understand what is a thread. Like example, you'll be using Word. Now that is one application. Word is one application. But in one application you'll be having multiple tasks running. Like example, spell checker will be running, will be typing, and at the same time you can do what? Printing also. So but one application is only doing what? Multiple tasks. So their spell checker is one execution, process of execution or part of the program. Okay, and this one, your typing now, that is another part of a program, and printing is another part of the program. And all these tasks have a separate path of execution now. Okay, they are not following one after the other. Okay, so they are having their own separate path of execution. So that part, separate part of a program is called as a thread. That separate part of a program is called as a thread. Understood? And having multiple threads in your program is called as what? Multithreading. Or having multiple path of execution. Multiple path of execution in a program is called as multithreading. Okay. So thread-based multitasking only is known as what now? Thread-based multitasking only is known as what? Multithreading. And this is related to whom now? Application developers, that is we. So we are supposed to learn what now? Multiprocessing or multithreading? Multithreading. Because we are not OS creators, we are application creators. Understood? So now when you are developing application, you can develop an application using any language. You can develop it in C, C++. Applications can be developed in any language. So whenever you want to develop an application, okay, obviously you will be having what? Multiple path of execution, or you will be having a multi-threaded application. Now why do you create multiple threads now? Question is the answer is very simple now. Question also simple, answer also simple. What is the answer? To put idle time to usage. Okay, because if you have a single threaded execution, no? If you have a single threaded execution, what happens? Till now you have seen all single threaded only. If you have single threaded execution, one task will complete and then the next task will start. And after that completes, then the third one will start. Means something like in Word. What happens? First you might start typing. After typing is completed, then spell checker will run. And after spell checker is running, then you will do printing. So it is going to be time consuming. Okay. And see when some tasks are getting running, there will be some idle time. Like you can't see when typing now, example. You can't match the speed of the processor. When you are typing, you can't match the speed of the processor. You think and type. So when you are typing, there is always some idle time. And that idle time can be put into usage for what? Printing or spell checking. Understood? So that is how we actually try to, that's the reason why we create multiple threads now. The reason why you create multiple threads is what? To put idle time to usage in your application. So in your application, when there are, otherwise say if you are going for single threaded, what happens? One task has to run after the other. So it will consume what? Too much of time. Understood? So in single threaded execution, what happens? There is performance degrade. There's performance degrade. To enhance the performance of your application, we go for multi-thread executions or multi-threaded program. We go for multi-threaded program. Are you clear? So now you understood now why we create multiple threads now? To put, simple, in one word, to put idle time to usage, or to use the idle time of the CPU. Understood? And the benefit of that is what? It increases your performance of the application. This is a very important interview question. Why do you do multi-threading, or what's the advantage of it? We do it for putting idle time to usage and for increasing the performance of the application. Very simple answer. Okay. So now see, when you create multiple threads, again, see, even though there are multiple executions happening, you feel that all the three are happening at the same time. But remember, okay, only one task will be executed at one particular moment. If you feel like three things are running, okay, but only one task will be executed at a particular moment of time. And when one is idle, the other one will be executing. Once it's idle, the other one will be executing. So that itself is called as context switching. So there's one terminology. Okay, it's called as context switching. Now switching from one context to another context is called as what? For execution. Switching from one process of execution to another process of execution is called as what? Context switching. So context switching will keep happening and it will go on executing. Now that context switching will be decided by whom now? See here, the context switching will be decided by JVM thread scheduler. Here, context switching will be decided by means, because see, we are writing Java program now. So it will be decided by whom now? JVM thread scheduler. Here who will decide this one now? In process based multitasking, here also context switching will happen, but who will do it? OS scheduler. The OS will decide, okay, which process to execute. Like here what will happen, it will decide whether to execute the word or whether to execute VLC player or whether to execute the browser. So here context switching will be decided by whom? Okay, so it will be switching now. Now to do context switching, there are so many algorithms. Let it be here or let it be here. To do context switching, there are so many algorithms. Like example, round robin, time slicing, understood. Then first come first job, then shortest job first. Like that, many algorithms are there. Okay, so depending on that, the scheduler will execute the task for you. Okay, the scheduler can be a OS scheduler or the scheduler can be a JVM thread scheduler. So OS scheduler is related to decide which process to execute or which program to execute. JVM thread scheduler is deciding which thread to execute or which separate path of execution to execute in your program. Are you clear with this? So this is one simple introduction I have given to what? Multithreading. Okay. So we are going to learn more about thread-based multitasking. Thread-based multitasking only is called as multithreading. Thread-based multitasking only is known as now multithreading. So that is ruled out for us because we are not OS creators, we are application creators. Are you clear with this much now? Okay, shall I clear all this now? Okay, see this now. Running more than one task concurrently at the same time is called what? Multitasking. Heading is multithreading, but first we are learning what is multitasking. Okay, so running more than one task concurrently at the same time is called multitasking, and it is done to use what? CPU idle time. There are two types of multitasking. What are the two types? One is process based multitasking or program based multitasking, just now which you wrote. The other one would be what? Thread-based multitasking, or also known as thread-based multitasking. This process-based multitasking is also known as what? Multi-processing or multi-programming. So it should be clear because these terminologies are very, very important. When you read books, they become very, very crucial. When you see a word multi-processing, okay, it is related to operating system. When you multi-programming, it is related to operating system. Multi-threading, yes, it comes to our application. So that is why I am stressing more on these words now. So thread-based multitasking, and that is also known as multitasking, also known as multithreading. Thread-based multitasking is only known as multithreading. Okay. Now some more details I have given here. Now running more than one process or a program concurrently is called what? Multiprocessing or multiprogramming. For example, using Microsoft Word, playing media player and at the same time using a browser, just now which I told you. Multi-threading means what? It is also known as thread-based multitasking. Running more than one execution in a process or program concurrently is called multi-threading. For example, when you use Microsoft Word, there will be many executions like spell checker, printing and user typing, all happening at the same time. So all the tasks will be happening at the same time. So we feel they are happening at the same time, but in reality only one will be getting executed. Okay, because the context switching in today's latest processor is very, very fast. The processors today, they switch from one task to another in a very fast manner, which is not noticeable to the human beings. So that is how they execute. Okay, fine. Now this is one of the most important interview question which you will get always generally. Difference between multitasking and multi-threading. Okay, first we'll see the definition. Process is nothing but what? A program. Process is nothing but a program. Multiprocessing is nothing but running multiple processes or programs concurrently. Now what is multi-threading? Thread is, first you understand what is a thread. Thread is nothing but a separate part of a program. Okay, multi-threading is nothing but running different parts of the same program concurrently or running multiple threads concurrently. Fine. Now this is called as heavyweight. Multiprocessing is heavyweight and all processes share what? Different memory space. They are heavyweight. But as compared to that, multi-threading is lightweight and all threads share the same memory space. Now context switching, one process to another is expensive here, but context switching from one execution to another is inexpensive. Data sharing and communication is also expensive, but data sharing and communication is inexpensive. This point, the fourth point, we'll be seeing with a good example. Practically you'll be seeing in code, and there you'll understand that fourth point very clearly. And now this one just rough diagram, what I given you, you can see this. Okay, in multi-processing, this is what happens. Every process will have what? Its own memory space. Every process will have its own memory space. But in this one, multi-threading, the program P1 will have what? Only one memory space. It might have 3 threads, but all the 3 threads will be using what? The same memory space. That's why it is called as lightweight. Understood? So first get the introduction properly, because when you create the threads it will be easy for you to understand. Yeah. Now first we'll finish off multiprocessing. A little overview I'll give you and we'll finish it off and we'll come to only multi-threading now. Okay. So what is multiprocessing now? Multiprocessing. So all the tasks will be executed by CPU. Even though it looks CPU can execute more than one task at a time. 1 second. All tasks will be executed by CPU. Even though it looks CPU can execute more than one task at a time, but practically it is not possible. CPU can execute only one task at a time. It will execute only one task at a time. As a user of computer, we can observe multiple programs are running concurrently, which is happening because of operating system, CPU scheduling algorithm. Some of the CPU scheduling algorithm used by the OS scheduler are some. There may be many, but we just have listed few. Round robin or time slicing, priority based or also known as preemptive, shortest job first, first come first serve. So like that many are there. But and see, the task of the above scheduling algorithm is switching the CPU from one task to another, or we can say allocating the CPU time for all the tasks which are started. Okay. Then next, among this, time slicing or priority based are very time slicing or round robin, or which one? Priority based are very popular algorithms used by many operating systems. Okay. See, Windows follows priority based and Unix follows what? Round robin. Just to give you an idea what is multiprocessing, I just given you some information. Don't go much into that because we are more concerned about multi-threading. Yes, we start off with multi-threading. What is a thread? Already I gave the introduction. These are definitely interview questions only. I put it as question and answers so that it will be easy for you. A thread is a part of a program which has a separate path of execution. Very simple definition. Okay. Then next, what is multi-threading? Multi-threading is a process of running what? Multiple threads concurrently or running different parts of the same program concurrently. A multi-threaded program contains 2 or more parts that can run concurrently. Till now your program is having single part. Till now what programs we wrote, they were having single part of path of execution or single part. but from now we can write programs which can have multiple parts also. Okay, so what is the advantage of doing multi-threading? Multi-threading is always done to use what? CPU idle time. It thus helps in increasing the performance of an application. Very simple reasons. Okay, subject looks big, but the reason is very simple here. So understand why you do it first. Now, why thread is lightweight? Okay, so whenever a thread is created within a program, it will not occupy any separate space. It is the same memory space. It will share the same memory space of the program itself. Just now I showed you the diagram. It will share the same memory space of the program. So it will not consume more resources also. Hence we say thread is lightweight process. Yeah, fine. Next. Now in a single threaded environment, what happens? Your program has to wait to finish a task completely and then move to the next task, which decreases the performance of the application in a single threaded environment. So whatever I told you just now, introduction, I'm putting it in points so that you understand. Yeah. So now see, Java gives full support to multi-threading with the help of its library. That's the excellent part of Java. For doing multi-threading in other languages, we literally what? Die, or it is impossible. So first you understand the concept and try to do it in other language. You'll see how difficult it is. But in Java I show you how to create a separate part of a program or a separate path of execution. It will be so simple, it is unbelievably simple. Understood? So Java's support to everything comes from its library. Everything, whatever you want to do, it comes from the library itself. Fine. Now, see, the JVM has a thread scheduler, as I told you. The JVM has what? The thread scheduler, which decides which thread to execute in your Java program. Okay. The JVM scheduler implementation varies for different JVM of different OS. Understood? You know, for every operating system, there is a different version of JVM. Okay. Now see, the JVM thread scheduler negotiates with the OS scheduler and finally decides which thread to execute. So this is where we come now. So your JVM thread scheduler will be using what? OS scheduler. It will be negotiating with and been deciding which thread to execute. So that is the reason a multi-threaded Java program execution will behave differently in what? Different operating systems. This is one of the things. They'll ask you why a multi-threaded Java program will run differently in different operating systems. This is one of the main reasons. So do not bother about these 4 points. After we complete multi-threading, you'll be getting a clear picture about these 4 points. Understood? Time being you understand as an overview, but when we complete it, then you'll understand very clearly these 4 points in depth. Clear? Fine. Now JVM creates. Now let's get into this one now. Threads now. Okay. So now we'll see now. See how if you want to create a child thread. Okay. You need something called as a main thread. Okay, so before we start creating other threads, first we'll understand there is something called as a main thread. You see, till now we have not created threads. Till now have we created threads? No. Even if you have not created any thread, by default, built in, one thread is starting off. Okay, and that thread is called as main thread. Understood? Till now we have not created threads. Yes or no? Did we create any threads? Did we create any thread means what? Did we create any path of execution, separate path of execution? See, one thing I'll tell you. When you are learning multi-threading now, okay, you should understand like this now. See, thread means, be clear with this one. Otherwise, when you are reading notes also, you will not understand. Thread means simple, replace. Fact means replace in your mind. When you are reading document or book or something, somewhere you are struck, you are not understanding something. Just replace the meaning of that with separate path of execution. Thread means execution, that's it. That's it. Understood? And small t. Thread means separate path of execution. And Java support for thread comes from a class called as thread. This is where you have to be very clear. Understood? So capital T means we are talking about a class now. Okay, small t means we are talking about what? Separate path of execution. So that is why I am introducing all the terminologies and the methodology to read the book. Clear? So class thread. It encapsulates what? A thread. Are you following now? Every class in Java encapsulates what? Something no. So class thread encapsulates a thread, or simple words, it encapsulates a separate path of execution. encapsulates the execution. Okay, till now we have not created any thread. Till now did we create any thread? Simply we are writing our program, it was getting executed. That execution is itself what? A thread. As soon as we say Java demo, one execution is happening now. That itself is what? A thread. Your program is completing now. But how does it happen? Let's see it with a simple example. Understood? So first I will introduce one thread called as main thread. Why this main thread is very important for us is, see, main thread is the one which starts or which executes main method. Okay, understand now. So if you want to create child thread or user thread, child threads are also known as, and this happens implicitly. Main thread, one second, is implicitly created by JVM. So first we'll understand this point. And when will this happen? When you say Java demo. When you say Java demo, Java command will start the JVM. So when you type the command Java demo, JVM will start. Okay, it will create one thread called as main thread. Understood? After creating the main thread, this thread, what it will do? It will put it into one group. One second, let me draw it clearly for you. The thread will be put into one group called as main group. You can group your threads. After creating thread now, you can put this thread in one group, this thread in another group, you can group it. But this is what JVM is doing. As soon as you say Java demo, one separate execution starts off. See, this is the execution. And the separate path of execution has been put into what? Main group. And this main thread is responsible to invoke what? Main method. Invokes main method. Class loading and all is common now. Java demo. What will happen? Java command will start the JVM and it will create one thread called as main thread. It will put the thread into main group. Then it will load the class. Which class? Demo.class. And in that class it will look for what? Main method and it will execute the main method. That is, from main method you know everything. But before main is called, I am telling you what's happening. Okay. Yes. So main thread. So which executes, main thread is the one which executes the main method. Clear? And it is implicitly created by JVM. Second, we can create child threads, or also they are known as user threads. Child thread is also known as user thread. Okay. And this is created by developers. Created by developers. And main method or main thread, anything, main method creates what? The child thread. Main method creates the child thread. You're following now? So first we have to understand this, and then we will see how to create the child threads. First we have to understand this, and then we'll see how to create the child threads. Clear? So we'll see an example for that best. What now? I'll give the introduction to what? Main thread. Whatever I told you here now, I'll give the what? With demo only I'll show you. You'll understand it very clearly. Clear? Is it clear now? Whatever I've written. So are you clear with these things now? Thread is what? Small t, separate path of execution. Capital T is what? Class thread. Capital T is what? It's a class which encapsulates what? A thread or a encapsulates a execution. Java demo. I mean, so there are two types of thread in Java. Okay, this will be created implicitly. There are two types of thread. Okay, main thread and child thread. So main thread will be created implicitly by the JVM itself, and child thread we will be creating. So first I'll give the demo of main thread. So we are going to study the library, that's it now, nothing else. Means first we understand the concept and how we do it with the help of Java library. Yes, coding will start with which one? See, we had stopped here. JVM creates one thread called as main thread, and main thread calls the main method. So I'll show you an example now. After that example you write this notes, because this document, this notes will be related to what? That program now. Okay, so till here you write whatever you want, but from here, from this part, you write it after you write that program. So let's see this now. So yes, we'll see the first program of multi-threading now. Okay, we'll create one workspace. In the workspace, we'll create a new workspace now. I'll go to core Java. Here I'll create something, a folder called as what? Multi-threading. The metadata will be created, as you know that. So where metadata is there, that becomes your workspace. Always open Eclipse where .metadata is present. First time it will be a bit slow. Create one project there, 01, your name as threads, any name you want to give, but preferably give logical names. This is the first project you are creating here. This is the project name. I'll increase the font size. We are using now. Okay, then you can create one package. Always try to save classes in a package. Make it a habit. Any package name you want to give, com.cluster I given. Okay, so let's see now. I'll write a new class called as ex1, example1. Your file names cannot start with numerics, so don't write 1. Okay, for what? File names. So ex1 main thread demo. I want main method now. Yes, this is the first program we are seeing now. So always whatever programs I got, if you want assignments, no, don't take any extra assignment. Whatever programs I am typing or you have got, try to type the same program without seeing. That's it. Understand and type. That's it. That's only your assignment. Don't try to go what? Deeper into typing your own logics and all that. First you understand what I have thought properly, then you can type whatever you want at a later stage. And I will be covering it. In the projects we will be doing it actually. There will be practically implementing it. So just like how I do. Begin main. Okay, fine. End main. So this is fine. Let's see. See this. This is when I say run as Java application, what happens? Internally what's happening? Java demo only is happening. Understood? So Java demo means what? The JVM starts. Understood? Then it will create one thread called as what? Main thread. That main thread, it will put it into one group called as main group. JVM only is doing all this. Okay. And after putting it into the main group, and the main thread will now execute the main method. Class will be loaded. Class will be loaded and the main thread executes the main method. Understood? Very simple. So it's happening now. But let us see now. Okay. If you want to see, now you want to get the information about this execution now. You want information about what? The current execution which is happening now. What is the name of the thread? What is the group it belongs to? That information you want to know. So nothing in Java. What do? You'll call a method. Very simple. So what I'll do now? Thread. T is equal to thread dot. See, there's a method called as current thread. See, current thread is a static method in class thread. Now you have to start understanding how I'm using the methods now. Current thread is a static method present in class thread. The return type of that is what? Thread. Understood? The return type of that is a class called as thread. This is Java now. Okay. So, and we are using the library. So we don't write any logic. We should know how to use the built-in classes now. And these built-in classes already contain the logic. These built-in classes, now what logic you want to write? You want to write what logic? You want to find out which thread is executing, the information about all that. Okay. Nothing you write, it's there in a method. But just call that method, you'll get it now. Okay, so now what it does is, it gets current thread method. What does current thread method do? Gets a reference to the current executing thread. So we are going to see too much of this API now. Understood? As I go on using this, you'll understand all these methods very clearly now. Current executing thread gets a reference to the current executing thread. Fine. Thread dot current thread. 1 second. Gets a reference to the current executing thread. Fine. Now simply say this. Sys out. Sorry. Current thread is, simply I'll print plus T. Nothing more I'll do. Just see now what happens. So what is it printing? Current thread is whatever is there in double quotes, it will print as it is. But what is the value of T you are seeing here? It's printing this much. Okay. This is called as name of the thread. The first one what you are seeing main, no? It's called as name of the thread. The second one is called as what? Priority of the thread. There's something called as priority, which will be seeing it. But the priority of main thread is what? 5. Okay. And it belongs to a group called as what? Main group. So get the point clearly here. So this is called as thread name or name of the thread. The first main what you're seeing is called what? Name of the thread. 5 is what? Priority of the thread. And this is what? Group of the thread. So main thread belongs to which group? Main group. So till now we have not created threads. Okay, first learn the main thread which is getting started or executing. Understood? So done. So once, and again, to be more precise, now what am I trying to teach you? What am I trying to teach you? Members of class thread. We are only learning means if I call this method, this will happen. If I call this method, this will happen. We are only learning what? Members. Again, open document, Java doc. Okay, see the methods now. We are learning all the methods of what? Class thread. And this is a very tough class. Which one? Class thread. Minimum to understand class thread we require 4 to 5 days. String class you understood in 1 day. Integer class you understood in 1 day. But some classes take a lot of time because one class is encapsulating how much of information you see now. A single class encapsulates how much of information you go on understanding now. So this much information it has. Now after this, now see what I'll do. T dot set. I can change the name of the thread. So what is the method I'm calling now? Set. There's a name. There's a method called as set name. What is the argument I have to pass? String. So I'll change this as cluster thread. Any name you want to use, that's your wish. Understood? Change name of the thread. You have changed it. Then what you do? Again you can print. See now what happens. After name change, what has changed? Main thread has changed to what? Cluster thread. Any name you want to give, that's your wish. Clear? So what is the method name you are learning now? Set name. Set name is used for what? Giving a name or changing a name to a thread. Okay. So we'll be seeing all these methods in depth now. Don't worry. So then, current thread. Okay. So then I'll change t.set. If I want, I can change the priority also, but I have to give an int value, and the int value for this, what it should be, is compulsory between 1 to 10 only. You cannot give an outside value. Okay, so you have to give compulsory int. Okay, so I'll give a value called as 7. Any value between 7 and 1 to 10 you give. We'll be seeing priority later, but right now what I'm changing? After priority change, see I'm printing now again. After priority change, you can see the output. What it prints? First it was this, then I changed the name, then I changed what? The priority. So it's printing what? 7. Yeah? Fine. Are you clear with the thing now? So class thread encapsulates what? Information about the executing thread. Understood? It will encapsulate. So we are working with the current thread now. Okay, which is executing, that is the main thread. Fine. Now see this, I'll put a loop for I is equal to 0, I less than 5, I plus plus, yeah, for int I is equal to 0, I plus, see the execution now. We are doing some iteration. That's also an execution now in your program. See how it executes. So you are executing a loop now. So this is all an execution process now. Fine. Now see this. Clearly you see the document now. The following things happen when a Java program starts execution when you say Java demo. JVM will create a thread group called main. JVM will create a thread with the name main. First it will create the group, then it will create the main thread. Then it will add the main thread to what? Main group. Then JVM will take the command line arguments, and based on the arguments a string array will be constructed. If you are giving some arguments, the class will be loaded into JVM, and main method will be invoked by passing the string array as an argument. From there you know fully what happens. So just when you say Java demo, these are the things which are happening. Are you clear? Till now any doubts? No? So we saw the execution which is started by the JVM now. So implicitly, whether you start means whether you want to create a separate execution or not, that's secondary. But without you creating a thread, you have already seen one execution which is happening now. Okay. Now when it comes to threads, there is something called as state of a thread. There is something called as state of the thread. So actually in Java, there are 5 states of the thread. Okay, I'll not cover all the 5 states. I'll be going through all the 5 states in the next session. But today I'll discuss about only 2 states. So in Java there are 5 states. Okay. So today I'll be discussing only about okay. The different states are, one is new state. The second one would be runnable state. Third one would be running state. Fourth one would be non-runnable state. So now we are slowly starting. If you understand all this, then we can create our threads and start writing our programs now. Okay. And the last one would be dead state. Understood? So now see, when you say Java demo, what was happening? The thread came into what? One state called as runnable state. Your main thread is there, no? First it will enter into what? Runnable state. From runnable state it will enter into a running state, and from running state it will enter into something called as dead state. So right now we are discussing only about 3 states. Today I might be concentrating on only 3 states. Later in the next session you will see all the other states. First you understand every state here. So when you say Java demo, the thread will go into runnable state. The JVM thread scheduler will always be keeping a watch on what? Only this state. So any thread when you create or whatever it is will be first in the runnable state. From there the JVM scheduler, thread scheduler, okay, what it will do? It will bring it into what? The running state. So always remember, only one thread at any point of time, only one thread will be in running state. Here you can have many threads. Here many threads can be there. In all state, not only this, runnable, blocked, dead, you can have many threads. But in running state, always one thread will be there. Many threads can be there. But right now I am discussing only which one? Runnable. Runnable, running and dead. Okay. Many threads can be in runnable state. See, new state, you can have many threads. Runnable state, many threads. Running state, only one. That you understand very clearly. You understand this. Non-runnable, you can have many. Dead state, also you can have many. Sorry. Okay, when you say Java demo now, what happened? The main thread entered the runnable state. After completing the runnable state, means from the runnable state it entered the running state, and then it entered the dead state. So we are having only one execution. That is why it doesn't make any difference. When I create child threads, then you'll get a clear idea about this picture. Are you clear with this? Okay. Now, after understanding this much, shall I clear all this now? There is one more state, okay, which I'll introduce today, but where I'll write it? 1 second. Just change the diagram. Sleeping state. One more state is there. Sorry for the diagram. Okay, sleeping state. From the sleeping state, it will go back to runnable state. So this program. The next change, what I'm going to do, that diagram is correct. The diagram is correct. You take this as a new diagram now. The diagram is correct what you have taken. Just I made manipulation. You take it as a new diagram, because now the next program which I'm going to execute is going to represent what? This particular thing now. Sleeping state. The sleeping state is also known as what? See, 1 second. Clearly understand. Non-runnable state means there are many here. Again, one is called as sleeping state. Other one will be waiting state, and the other one will be blocked state. See, from interview point of view, you have to tell only what? 5 states. How many means when they ask you how many states of a thread are there, these are the 5 states. Which are the 5 states? New state, runnable state, running state, non-runnable state, dead state. In non-runnable state, you have got 3 more. Called as what? Sleeping state, waiting state, block state. So now I'll show you what is non-runnable state. In non-runnable, which one I am picking? Sleeping state. In non-runnable, I am picking what? sleeping state. So now I'll start the main thread. We have already we saw the main thread now. So main thread will enter what? Runnable state. It will be in the running state. It will be in the running state. So what I'll do, I'll put it to the sleeping state now. Okay, before the thread is dead, what will I do? I'll put it to sleeping state. So how do you put a thread from running state to sleeping state? By calling a sleep method. I'll use some sleep method and use some argument. And when that time is over, when that sleeping time is over, it will come back to what? From sleeping state, it will come back to what? Runnable state. Again, it's from runnable state, it will come to running state. So this diagram is very, very important for you to understand. Okay, this diagram will still increase more. First diagram you saw, this is the second diagram. Understood? The next diagram which I show you will be having all the states. That time you will understand still more clearly. So when will it come from sleeping state to runnable state? When sleeping time is over. Or I'll write it like this. Automatically it will come. When sleeping time is over, it will come to sleeping time is over, it will come to runnable state. So remember this, I am going to introduce which method now? Sleep method now. So when you call sleep method, you have to send some argument, we'll see it. It will come to sleeping state, and when the time is over, it will go back to runnable state. And from runnable state, again it will come to running state. So remember, there is only one point of entry into what? Running state. A thread can always enter a running state from what? Runnable state only. That is what I am trying to project now. Understood? A thread will always enter a running state only from what? Runnable state. Keep this point in mind now. Clear? Understood? So it will go here, and from here only it will come. It might go to what? Other states. From here it will go to running, it will go back to runnable. From running it will go to sleep. From running it will go to wait. Wherever it goes. Again, to enter back into the running state, it has to come back to runnable only, and from runnable only it has to come to running. So this life cycle of a thread is a big subject which I'll be covering tomorrow. Understood? Today we can't do it because first I have to introduce you how to create a child thread. That is my main intention. So I'm rushing towards what? Creating a child thread. So that is where my focus is now. Clear this? Okay. So just anyway, I'll just give you which one now? Information. We'll see the output of this now. That's it now. And then I'll create a child thread. Shall I clear all this now? So as I told you, you are seeing now multithreading is a big subject. It's opening up. Okay, Java gives excellent support to this. So one side you are learning the concept, and the other side you are seeing the support from the library. You understand that point. So if at all I want to put the thread into sleeping state, all I am going to do is what now? Call sleep method. One method is all you are calling, but concept is so big now. So behind the scene is the concept. Okay, and then to implement that concept, we start using the Java library. So that is where you have problems. I told you initial problems. What are your initial problems? You don't know the concept, but you want to code. That is your problem. So coding is very simple as long as you understand the concept. Understood? So always try to understand concepts rather than paying more attention to output. Now see this, I'll do. So what I'll do now, see you saw the output now. Just see this output now, how fast it's happening. Within a fraction of a second the output is getting completed. Yes or no? The output is over. Now see what I'll do. I'll put the thread to sleep now. In the loop I'll put. You can call it anyway. Thread dot. See, I'm calling a method sleep. There are two overloaded methods. There are two over methods, and I have to pass argument of type long, and it is millis. Millis means milliseconds. How many milliseconds you want to put in to sleep? The other one is there, millis and nanos. Okay, so first we'll work with which one? Millis, and I'll pass 1000 milliseconds. 1000 milliseconds means what? 1 second. But it gives me an error. Why? It gives me an error because that method throws an exception. See this? Interrupted exception. So what you have to do? Put it in try catch, and it is a checked exception. So you are forced to write what? Try catch. Understood? So this is how you do the exception handling. So I can write try interrupted exception. You can give any message, that's your wish. Main thread interrupted. Okay, so end main. So let's see the program this time now. See the output now. Can you see the execution? What is happening? It will from runnable state it moved into running. From running it went into sleeping. In sleeping it was sleeping for 1 second. From sleeping it came back to runnable. From runnable it came back to running and continuous execution. So since there is only one thread, you can just understand this a little. Okay, when I create more threads, you'll start getting a clear idea. Understood? So are you feeling the execution now? Are you feeling the execution? Okay. So now see, to get the same output in C language and C++ language, whatever language, it's very, very difficult. Okay, like if I ask you write a program, okay, to get control over the current executing thread in C language and ask you to put the thread to sleep in C language, how difficult it is? Or in C++. And just a simple thing now. Means put the current executing thread into what? Sleep in C or C++ means, or get the information, put it to sleep and all. It's so difficult. But in Java we almost all did it in what? 1, 2, 3, 4 lines. Just some 3, 4 methods we called. So always observe, I am introducing the library for you. So what is the method I introduce next? Sleep. Sleep method puts the current executing thread to sleep. Whichever thread is executing now, it will put that to sleep. Understood? Okay, if you want you can increase the time. If you want you can make it to what? 2000 also. But it will sleep for what now? 2 seconds. But don't give more time because you will have to wait. Okay, till it completes the execution. So it's executing. See that? 1, 2, 3, 4, 5. So it's executing. From runnable it was in running. In running state, what did you do? You called the sleep method and sent an argument of what? 2000. So it went to sleeping state. After the 2 seconds is over, then it will come back to what? Runnable. It will not come back to running. Okay. So then from runnable it will come to running state. Again it will be executing. Again it goes to sleeping. Like this, the flow will go on happening. Are you clear with this? Okay. So this is just a simple introduction to what I'm giving to you about threads now. Okay, one more thing. See, this is a static method. Again, thread.sleep is what? Static method. We are working with some static methods. We are working with some instance methods. Set name, set priority are all what? Instance methods. Okay. Current thread. Sleep is what? Static method. So you should observe the members, how we are working. Fine, next. There's one more way. T.sleep also you can call. This also will work. There's no output here will not be any different. But there is a big difference between thread.sleep and t.sleep. Here no difference. Why means first see the output. Same output, no change. Okay, but the difference between these two is thread.sleep means the current executing thread will be put to sleep. Okay, means wherever you call this method, one method will be executed, one thread will be executing this program now. That thread will be put to sleep. T.sleep means T is referring to which thread that will be put to sleep. So with more programs you will understand this concept. T is referring to which thread. Now you can have multiple threads now. So that time what will happen? T will be referring, sometimes T will be referring to one particular thread. So T.sleep means that particular thread will be put to sleep. But if I say thread.sleep, if I call the static method, any thread which is executing that will be put into sleep. But here both are same because there is only one thread. Thread.sleep means the current executing thread is put to sleep. T.sleep means T is referring to which thread? main thread. So that is why that will also put to sleep. So here you will not notice the difference, but there is difference which I will be showing you later. So are you clear with these things now? Any questions here? Any questions? So understood the main thread? Understood how it is executing? Okay, fine. Now we'll come to the next important point now. How to create child threads or user threads. Child threads are also known as user threads. Are you comfortable about main thread now? How it is executing? And do not bother much about life cycle, because a detailed subject is there. One full session I'll be taking only on what? Life cycle of a thread. Full with notes I'll give you in detail. Timing, this diagram was explaining you that program. Whatever diagram I wrote now here, it was explaining you that particular program. So if at all you want to create a separate path of execution in Java, it's very simple. Okay. But before we get into that, first we'll understand the support from the Java library. There's one interface called as runnable. In Java, there's an interface called as runnable. If it's an interface, what will it have? Abstract method, nothing else. And the abstract method which this has is called as run method. It's having one method called as run. Understand the library first. And this interface has already been implemented by a class called as thread. If we use the thread class now, so class thread is what? It is implements. So it's having many method. Implement, sorry, runnable. Just now you saw there are many methods. Which are the different methods you saw in class thread? Sleep, current thread, set name, set priority, so many methods you saw. But along with that, it is overriding what? Run method. So this is very important now. Right now, this is very important. So class thread overrides run method. And for your information, this is an interface, this is a class, agreed. But these two will be definitely in a package now. Java will not keep the classes wherever you want. It will keep it in what? In a package called as? Can you guess? So these both of them are present in the lang package. So you don't have to import anything now. As not importing class thread, notice now. So whatever is required for what? Basic programming has all been kept in the lang package. Basic programming, whatever is required, has been kept in the lang package. Are you clear with this diagram now? So now we'll see how to create a child thread. If you get this, this is the only support you have got. Within this only the whole subject of what? Multithreading is there in Java. Multithreading is separate concept, but the entire concept of multithreading has been implemented only with these two things now. What? Thread and runnable. That's it. So simple it is. Now how do you create a separate thread or a separate path of execution in Java? Question is that, very simple. How do you create a separate path of execution in Java? Very simple. Creating, the subject is creating child thread or user threads. Only one thing, what will you do? Override run method. That's it, over. A separate path of execution is done. Only one step. Can't you do this much? It's very simple now. Whatever you want to execute in a separate path, just write the logic in what? Override run method. That's it. In the run method you write it. So when you write the run method, supposing I'll write some logics now. See this. So public void run. You'll write. But every method should be kept in a class now. That is very important, because Java is what? Object oriented language. You have to write it in a class. Okay. So see, whatever you want to execute in a separate path of execution, you override it in run method. But generally this is very simple, as I told you. Along with this, you have to understand one more thing. Java Sun tells, if you want to create a thread in Java, there are two ways. Okay, if you want to create a thread in Java, Sun is telling that. Sun company is telling what? If you want to create a thread in Java, there are two ways. One is by extending thread class. Second one is by implementing what? Runnable interface. In both the cases, you are doing what? Overriding run method only. That's it. Whatever the case. Okay, there are two ways to create the thread now. One by extending thread class. Other one by implementing runnable. I'll show you both. Okay, then we'll decide which one is good, which one is bad. So now see this. So this is one way. See, there are two ways to create child thread in Java. First one is what? Extend class thread. Second, implement interface runnable. So in the interview, this is a very important interview question now. How do you create a separate a thread in Java? Okay. See now, there are two steps you are doing now. Step one is what? Override the run method. Step two is what? You can do that by either extending class thread or by overriding a run method. That's it. Now see, this is what you will write your logic now. Write your logic. That's it. Whatever you want to execute in a separate path, write your logic. Business logic like printing or whatever you want to do now. Write it in a separate place. Now see the syntax now. I'm showing you the syntax. This is syntax. Again, I show you the syntax for what? Syntax with by extending. So syntax with class thread. What you will do? Class thread. That's it. Public void run. You know the rules for overriding now? Access specifier, return type name. So this is it. That's it. You have created a separate path of execution, nothing more. Now other syntax with what? This is syntax. I'll write the code and show. Interface runnable. So what will you do? Sorry. 1 second. Class. You have to extend now. My thread extends thread. See this, that's all. Here, write your logic. Here, class my runnable implements what? Runnable. Here also, what will you do? Override, that's it. See, first I'll be showing you this, then we'll come back to this. Are you clear? First you understand one, then we'll see the other one. It's very simple. And then what will you do? You'll create an object and call the start method. That's it. Hardly 1, 2, 3 steps are there. If you do it, your thread has been created. Child thread has been created. Should I clear all this? Should I clear all this now? So I'll be going with the first one. Which one? Extending class thread. See, I've shown you how to type the first program. Other programs I already typed. Okay. So I'll show you now. 1 second. See. I'll delete this project because I already got a project, ready project, which is having all the examples. In Eclipse, see now what I'll do. I'll show you importing projects. Delete this project. There's one threads I already got on projects here. It is there, which contains all the examples which I want to show you. This I'll take and put it into water. Right now there is no project. I delete it now. I'll paste it. Okay. Then I'll again open Eclipse. You should know how to use Eclipse. Yeah. It's called as importing project. Any project which is there, no ready project, you can you should know how to make it up and running in Eclipse. Right now it's not showing you. Is it showing you here? No. 01 threads. I already deleted now, but I pasted there. But still it is not visible here. So now what you do? Right click, import, general, existing projects into workspace. Next, it will only pick and say select root directory browse. It will only pick where it is. Multithreading. It is already selected. Just say okay. In multithreading folder you want this one now project. In that folder you want this project. Now say yes. Copy projects into workspace, finish. Now that project is there. This is the project which I had already coded. Previous project I deleted, and in this project I am already having what? So many examples. So always use import for what? So this is one more easy way I have shown you. So since I show you more easy ways, doesn't mean that you don't code. Compulsory what you have to do. I have told you prior itself. Without coding you can't get a job in Java. Very simple as that. Okay, because in company also you have to code now. Here everything you will see output, you will understand, but actually you will not be able to code later. So better you code. Just I am showing you easy ways, like if you find any example in internet, if you want to run my programs, how you can get it instantly up and running. Finished? Fine. Now let's see how to create a child thread. We will come back to the topic. Very simple. See this. Now say, there are other things here. In this class I have written M1, M2 method. Don't bother about that now, right now. So what you are doing now? My thread extends what? Thread no. Run method is there no. Understood? So here you can write your logic. Yes or no? Whatever logic you want you write now. Whatever logic you want you write. Now these extra methods you forget, M1, M2. So my thread is having what? Overridden run method. Apart from overriding it can have what? Extra methods. Leave about the extra methods. So done. It is ready. So next see, to how do you create? See, this is how. See, there are 3 steps. If you want to create a thread by extending class thread, if you want to create a thread by extending class thread, there are only 3 steps. First, define your thread. Define your thread means define what logic you want to execute. Second step, you create the thread objects. Here, my thread empty is equal to what? New my thread. Create an object of it, bring it into existence now. That rule will continue. Always create an object. But as soon as you create an object, this thread is not going to execute. Or it means as soon as you create an object, okay, it is not going to execute. To execute, what you have to say is call the start method. Empty dot start. So as soon as you say start, what happens? That separate path of execution starts. Now main thread will execute separately. This one will execute separately. There are 2 paths of execution. That's very simple here. See now? See, main begins execution, and it has created the thread and it has started also. But after creating the start, you can notice the output here first. Begin main. After begin main, what is happening? Back in main, end main. These 2 statements are getting executed. See here? And after that thread completes execution, which is what is happening now? Child thread and begin child thread and end child thread is getting executed. This output. So they are getting executed separately. Okay, earlier what was happening? After all those statements were getting executed, then your main method was getting completed. Okay, but now see, again I am running the output. So there are two threads in a program now. What is that? One is the child thread and the other one is the main thread. But creating it was very simple now. How did you create it? How did you create a separate path of execution? By just writing what? Extends thread, overriding what? Run method, creating the object, calling what? Start. Finished, over. So as soon as you say start, many things happen. Right now, and that is the subject what I will be taking next. That is where the life cycle of the thread starts. Understood? So don't bother too much about this, but just learn how to create a thread now. Are you clear with this? Okay. Now, let us see the program what is happening now. See, after writing it, see this is what you have done now. Class my thread extends thread public void run I'm just writing the same program which you saw just now, the output. So you can write your logics like this, continuous. Okay, so that's it, very simple. Now what will I do next? Class demo. Here what I am doing, I'll have the main method. So what did I do? SOP begin main and I created my thread. Empty is the variable name, is equal to new my thread and I said empty dot start. Then I said SOP end main. A very important let's see what happens exactly now. See here, when you say my thread empty is equal to new my thread, one object is created, that's all. Code will come into existence. Okay, but actually when you say empty dot start, okay, one separate stack gets created. One separate stack gets created. Actually in Java, a thread is nothing but what? A different stack in Java. First, when you start this program, see this what's happening. When you start the program here, Java demo, when you type, exactly what is happening, you know. First, there will be one main stack. One means main thread is nothing but main stack. Now, what is this stack doing? Means what is this method doing? Calling empty dot start. So when it says empty dot start, this is called as main stack. Or main thread, this is called as, we will name it as A stack, simple. Stack called as A. So as soon as you say start, okay, one more new stack will be created. One more new stack will be created, and in this stack you will have the run method. That run method is there now, that will be present here. Understood? So this run method can call other methods, we will see later. But this is where you will have the run method. So this is called as B stack. How many stacks are there now? 2 stacks. So now context switching will be happening like this. Your context switching will be happening between what? A stack and B stack. Sometimes it will go and execute the code from A stack, sometimes A method, sometimes it will go and execute the logic from what? This run method. Like this, the context switching will go on happening now. So whenever you create a thread now, either by extending class thread or by implementing runnable interface, story is same. Functionality wise, see there is no difference. If you create a thread by extending class thread or implementing runnable interface, functionality wise there is no difference. The difference only will come in design. Okay, we'll see that later. Okay, what design and all we'll see later. But as soon as you create a thread, what happens? Either case, one separate stack gets created like this. Understood? So once it is created, now let's come to our this one now. Say when you say start, when you call the start method, there are many things which happen. When you call start method, what happens? Step number 1, a new call stack will be created. First step. A new call stack will be created. One second. A new thread means I'm telling you what, my thread empty is equal to mu my thread is not a big thing for you. It's only about what? An object getting created. I'm explaining this statement now. What is happening in start? Okay. So a new thread is created with a new call stack and run method will be put into bottom of the stack. Are you following? Next, the new thread moves from what? Can you guess? New state to runnable state. So we are coming up with one more state now. Which one is that? New state. To what? Runnable. So when you call to start method, two things happen. These two things should happen, otherwise your thread will not execute. Understood now? A new thread is created in a new call stack and run method will be put into bottom of the stack. The new thread moves from new state to runnable state. So the same thing I am telling you now. What has happened now? A new thread is created with a new call stack and run method will be put into the bottom of the stack. Okay. The new thread moves from which one now? The second point now. New state to runnable state. So means, see, this is new state. From new state, what will happen? The new thread will move into a state called as a runnable state. And from runnable state, it will move into running state and then it will move into dead state. This is the flow now. Okay. So now say, let's look into this program now. Okay. When I say, see now, main thread had begun execution. When the main thread had begun execution, where was the main thread? Main thread was present in running state. Okay, when it created a new thread, okay, where did the thread go now? Runnable state. But I told you already, okay, so child thread is sitting here, main thread is running where? Running state. At one point of time only one thread is running in which state? Running state. So main thread is present here. And where is child thread? Here. So this is where they are present. So after main thread completes execution and goes to dead state, then what's happening? Child thread will come to running state and then it completes the execution. That's the actual flow what you're seeing here. Are you comfortable with this now? The child thread will come from runnable state to running state. It also will complete the execution and it will get the output. And do not expect that you will get always the same output. Sometimes it will be unpredictable. Okay, what will happen? Main thread will execute. After executing, means main thread will create what? Main thread will create the child thread and it will start it. As soon as it starts now, sometimes main thread will do what? Go back to runnable. So this is what I will be covering tomorrow, life cycle. So do not expect always this will happen. Sometimes you will be seeing output as what? Main thread completing first and then, right now you saw main thread first completing and then child thread next completing. Sometimes if you see the output as what? First child thread completing and main thread completing, don't get astonished. It is going to happen. Because it depends on what? Scheduler. The scheduler will decide which thread to bring from runnable state to running state. The scheduler will decide which thread to bring from runnable state to running state. So see, one output, one type of output can be what? First, this is first kind of output. Sometimes you'll get like this. Scenario 1, I'll name it as scenario 1. First, main completes. Means main method completes. Second, what will happen? Child thread will, or main thread completes. Then child thread completes. This is scenario 1. Scenario 2 also will be there. But what will happen? First, child thread will complete, and then main thread completes. So let me explain you this scenario first, which we are seeing right now. The first scenario I will explain. First scenario. What happened? The main thread was in running state. It created the child thread. The child thread was put into what? Runnable state. It was here only. Child thread is here. Main thread is still running, and it completed. Understood? So that's why you saw what? End of main and then child thread. Sometimes you will see what output, sometimes. Okay. After creating the child thread, what will happen, main thread will go back to what? Runnable state. Now child thread is also in what? Runnable state. Main thread is also in what? Runnable state. Both are there. Because after creating the child thread, the main thread has gone back to runnable state. Why and all the reasons we'll see later. Why the main thread will go to runnable state back to, or why the running thread goes back to runnable state and all that we'll see later. But right now what is the scenario? Both the threads are in the runnable state. At that time, what? The scheduler, the JVM scheduler will decide. It might decide to bring what? The child thread into running state. That will complete execution, and then the other thread, which one? The main thread, which is there in that state, will come to running state, and that will complete the execution. But clearly we are seeing what? Two separate path of execution this time. They are not linked. That is a separate path of execution. This is a separate path of execution. So you should be ready to understand both the scenario. Are you clear with this? And that's what I am telling, because the output in multi-threading, you can't predict which one will execute first and which one will execute next, because it depends on a lot of factors. What are the factors? The JVM thread scheduler, the OS scheduler, the CPU processing speed, many factors are there. So we can't exactly predict what will be the output. Are you clear with all this now? Any questions are there? Any questions are there? No? Okay, so when you call the start method, these things will happen, and we'll be seeing more in depth of this in what? Life cycle, and we're talking about all this. Shall I clear this diagram? Okay. Now see, a small change I'll do here. If you want, I'll make you understand the stack now. What is it? See, I can write other methods in this class. Which one? This one now. Okay, and what I'll do? SOP, begin M1, end M1. Again in M2, I'll write SOP, begin M2, SOP, end M2. Just modifying the same program. Nothing. See what will run method do now? Here, it will invoke M1 method. What is run doing now? See, we will never write all the logic where now? We will never write what? All the logic in main. Similarly, we will not write all the logic in what? Run. Because that's a separate path, this is a separate path. So all the logic, what we do? We write it in other methods like this. So what I am trying to say right now is, run method can call what? Other methods. It can create objects of other classes also. Right now I am calling M1 in the same class. But why do you want to write the logic in this class itself? You can write it in what? Some other class also. So that time what will you do? Create an object of that class and invoke that method in run method. So run method can do anything now. It can call method present in the same class, or it can call methods present in different class. How you know how to call the methods in a different class? Create object and call it. Anything you can do. So that's what I'm trying to show. And next, this M1 method will call what? M2. All this is happening now. So this time when you create a thread, what happens? A new call stack is created. Now understand the stack. Main method has called what? Start. And now this one, when the run method is created, what is happening? M1 is there, M2 is there. See? So here one separate stack, here one separate stack now. So M1 and M2 are coming under what stack? A separate stack, B stack. Main thread, if main method calls any other method directly, like supposingly I write here, box B is equal to new box B dot volume. So where will volume method come now? Into this stack. Understanding now how they get separated. So volume method will be coming under, because I created the object where? In main method. So that is related to what? Main thread. So like this, that's a separate stack, this is a separate stack. This will execute separately, this will execute separately. Are you clear with this? Are you clear with this flow now? So that's what I mean by a stack. So in Java, a thread is nothing but what? A separate stack. A separate path of execution. This is how they have designed it in Java. Very simple. Are you clear with this? So what is the concept you understood now? Very simple concept. One run method can call what? Other methods. Because we don't write all, see, if I am writing an application will have how many lines of logic? Understand. It will not have simple SOP like what? Begin child thread, end child thread. You will be writing plenty of lines of code. So all that code you can't write it in what? Run method. So you will definitely write it in other methods, and those methods will be kept in what? Other classes. You can create objects, call that, all that will happen. Are you clear with this? Yeah? So shall I show the output of this now? Okay. Shall I clear? It's the same program what is there in the Eclipse what I have written here. Shall I clear now everything? You should have maintained the stack, I think. Okay, 1 second. New state. What I had written? Runnable, running, and dead state. I'll explain this example with this diagram now. One more is the stack now. A stack, B stack. A stack is having main method, B stack is having run method. This is calling start, so fine. And we can call other methods also, volume, gillium and all that, you can go on calling. But run method right now what it is doing, it's calling M1 and M2. And in run also you can say what? Box B is equal to new box if you want. If you in run method also you can say what? Box B is equal to new box and call volume method there also, wherever you want, that's your wish. Understood? So, or I'll say like if I want I can call one in M2 means okay, like this it goes on, the stack goes on. So let's see the output now. I'll enable this comment what I had done earlier. Program to create what? A child thread, yes, M1. And now see, we have to invoke what? M1 and M2. But they will not be so simple. They'll be having big logics. Clear? So see this. Same program, just I have added some more methods and it is calling now. See back in main, so you can see main is only completing first every time. But sometimes it's unpredictable, as I told you, because what happens? Main thread created the child thread. Child thread moves into runnable. Child thread is moving into runnable. Main thread is completing running state to dead state. Now child thread will come from runnable to running and complete it. So when run method is executing, notice now, begin of child thread, what's happening? See the output. Begin of child thread, M1 is invoked. M1, now you can see the begin of child thread, now see the output here. Begin M1, after M1 will invoke what? M2 will invoke, okay, complete the execution and end of M2, end of M1 and end of child thread. That's a separate stack. That is getting executed separately, this is getting executed separately. Are you clear with this? Tomorrow I'll show you where the main method will complete what? last. All that I'll be showing you tomorrow. Okay. Are you clear with this? Here, almost all in this program, main will only be completing first in this program. And later programs we'll see like main will be completing what? In the last. Are you clear with this? Any questions? Okay. Now see, we'll do by implementing what? Interface. Very simple, that's it. We'll implement runnable. Understood? I'll write the code if you want first. What will you do? Class my runnable implements runnable, override run, write your logic, inside child thread or something you write. That's it, over. Now what will you do? Class demo PSVM. See, first create an object of my runnable. My runnable MR is equal to new my runnable. Create an object of this class. First bring the code into existence, sir. First always bring the code into existence. Which code you want to bring into existence, bring it. After that you say thread T is equal to new thread and pass what? This runnable object. End of the day when you create the thread object now, logic is what? It should have run method. Either from what? By extending or by implementing. So I created the thread object. In the thread object what are you giving now? The run method which is present where now? Runnable class. Same over. Next is what? T dot start. If you want you can have begin main, end main, that's your wish. Over. End of the day what you know? You see to that in the stack a run method is there. You do it by what? Either extending class thread or by implementing runnable. Your wish. Same story. So as soon as you say new now what happens? First you are creating the runnable object, and when you create the thread object what happens here? One separate object gets created. When you say start now, I gave the notes now what happens when you say start? Same thing. A new call stack will be created and the thread will be put into what? Runnable state. When you say start, remember two things will happen. What is step 1? This one, and step 2 will be this one. Creating a separate stack and then putting it into runnable state. Here runnable state, here it will put. There are two things which happen. I already told you when you call the start method what happens. Same. Functionality wise there is no difference. Now we'll see, tomorrow I will discuss why they are given two approaches for creating a thread. And maximum we use what? This one only. Can you guess why? Okay, let's complete it off. Which one is better? See, to see creating a thread by extending class thread is simple and easy. But if you create a thread like this, one step is extra. That's all. And it looks little confusing, that's it. But this is always advisable. Why you know? Can you guess? See here, we are decoupling the business logic and the thread. Understand that. We are decoupling what? There are two activities you want to do. One is the logic and the other one is the thread. It's always advisable to what? Decouple both of them. So now logic is here, thread is here. Tomorrow you don't want that logic in this thread. What I can do? I can change the logic now. So from design point of view it becomes very important. But in class thread what happens? In class thread it is tightly coupled. You are actually getting all the functionality of class thread into your thread. So there are many drawbacks. See, I'll tell you the drawbacks one by one. If you extend the class thread, what is the drawback? Your class will inherit all the functionality now. Yes or no? Simply it's an override. Understood? So simply it's an override. Second thing is what? It's tight coupling. You are tightly coupling the thread with the business logic, which is a very bad design according to oops, we should not tightly couple, always we should separate the code. Okay, and one more problem is you can't extend any other class. If you extend class thread, no, you can't extend any other class. So these are the three problems, because if if a class extends one class, finished. Understood? If your class extends one class, finished, what will happen? It cannot extend any other class. So these are the three main reasons. One is you can't extend another class, second one is you are inheriting all the extra functionality, third one is you are tightly coupling the business logic with the thread. But here what happens? Now see the advantage. This class, my runnable class, can extend another class, no? It can extend another class, no? Because in Java only you can have what? Multi-level inheritance, not multiple. So that's why I can extend here. But when you extend thread, that time you can't extend any other class. But here I can extend. Like I can write my runnable extends hello implements runnable. I can do inheritance. Then second thing, we are decoupling what? Business logic and the thread. So these are the advantages. And this is the difference between creating a thread by extending class thread and implementing runnable. Functionality wise there is no difference. Only from the coding design point of view, we code now, from that design point of view there is difference. Functionality wise there is no difference. Clear this? So now how do you create a thread by implementing? Step 1, write your logic. Step 2, what? Create the thread instance. Create the runnable object. Pass the runnable object to what? To the constructor of thread. You open the constructor of thread today. So it needs what? An object of type runnable. It needs an object of type runnable. So it's an interface now. Instead, what will I do? You know how to send an interface as an argument? Create an object of the class, implementing the interface, send it. We learned it in Java. Understood? So then next part, call the start method. You understood the syntax now? If you open the document, Java doc, thread document, it will tell pass an argument of type runnable. But runnable is an interface. So I'll create an object of the class implementing the interface, and that's it. 4 steps. So this is ideal, and most of the programs will be seeing like this only now. How to create multiple threads, we'll be doing it like this itself. Clear? So I'll show you the output. Again, output will you know now what it is, same output, but only by what? We are implementing, we are doing. Again, this you can have what? M1 method, M2 method. Again you can have a separate stack here. Now run will call what? M1 will call what? M2, story can continue. Same syntax what I wrote earlier. Clear? If you want to write begin M1, begin M2, that you write. Clear this? Should I clear this and see the output? Let's see the output now. I'm clearing this now. It's the same thing. Can you see this? Main runnable implements runnable. You're overriding run. Extra methods you want to write. Okay, that's your wish. Or write the extra methods in other classes. Create object of other classes in run method and invoke it. Same story. Here what did I do? Created the object, pass it into the constructor of a thread, and I'll call the start method. That's it. Almost all same output you'll be seeing. Begin main, end main, begin of child thread, begin M1, begin M2, same flow. There's no difference. Yeah, here what is happening? Main thread completed, main thread created the child thread and it put the thread into, you refer to your diagram. Okay, main thread was created the child thread and put the child thread into what? Runnable state. It completed the execution. Okay, and it went to dead state. Now when the running state is free, the JVM thread scheduler will bring the child thread from runnable state to running state, complete the execution and put it into dead state. This is the flow. Yeah? Yeah, this is scenario 1. Scenario 2 can be what? Again, main thread can execute sometimes before the child thread, which we'll be seeing tomorrow. Clear? Okay. So then, see this. One thing last we'll see now. The main thread, remember this, do not forget. This is the summary what you are seeing today. The main thread always looks for what? Main method. Remember that. Main method with what? String args. Compulsory to look for main method with string array. Clear? Now, user thread which you create or child thread which you create will always look for, means J will look for what? Always look for run method. If you create your thread, JVM will look for what? Run method in it. If you create your thread, understood now? JVM will look for run method in it. So that's what we do. When we extend, we override, or when you implement, what we do? Pass the runnable object to thread object. That is where it's you're telling, do not execute the run method which is there in class thread. See in this, when you do this, implementing, what are you trying to say is, do not try to execute the run method in your class, execute the run method in runnable object. That's what you are trying to say. Clear? Okay, but when you extend thread, it's already having it. It will execute the same run. So that's the reason we tell this. Otherwise, what will happen? Thread is already having on it's a class which is implementing what? Runnable. It will execute that logic. Understood? So always better you send your runnable object. That's it. Okay, anyway, just these two things you understand now. That's more than sufficient. And if you want, you can open the Java doc. Which one? And you can see the class thread. What are the members? Class thread in Java. Documentation you can open. And yes, you have got it. See, this is the old one, you know, no? Old and new. So what is the one we used? Say I used thread T is equal to new thread of what? This one, no? Yes or no? Then what are the other members? Many methods are deprecated, we will discuss that. Current thread, return type is what? Thread, static, then what? Set name. Now you can call get set name and set priority. Okay, set name, return type is what? Void. Argument what you have to pass is string. Set priority, whatever you saw, sleep, let's see, I use this and I passed milliseconds. That's it. You can go in detail. What I did, it will tell you. First, concept is separate. You first understand the concept of multi-threading and how is Java giving the support from the library is different. So parallelly we will be learning two things. And your problem is you don't know multi-threading. You understanding? So that is where the difficulty is coming out now. Now don't blame Java is difficult. You tell you don't know the concept of multi-threading, then I'll agree. Okay, if you know multi-threading, then Java support for multi-threading is damn simple. That's how it is balanced. So always in Java we learn concepts like this. One concept will be there. For one particular concept there will be on library support. Understood? Like if you want to get information about a thread, thread.current thread, all that you will do. If you want to put a thread to sleep, sleep. If you want to start a thread, start. Such simple. It's a support from the library. Are you clear? And finally the document we'll see now. See, if you want to create, if you want, we can also write our own threads. Threads written by us are called as what? Child threads or user threads. Now JVM starts the main thread and we can start the user thread or child thread from main method. Every thread in Java has a separate call stack, which I showed you, explained you. Understood? Sun has provided two different ways to create the child threads. One is by extending class thread. The second one is by implementing interface runnable. Note, in both the cases you override the run method and you write your logic inside that method you want to execute in a separate thread. Both the cases. Okay. The run method can call other methods, create objects, etc. Clear? Now following are the steps to create and execute a thread when you extend class thread. I put it in simple statement. What? First step one, what? Write a class by extending class thread and define the thread by overriding the run method. Step 2 is what? Create a thread by instantiating that class. Step 3 is what? Start the thread by calling start method. Over. A separate path of execution starts off. Other one is by implementing interface runnable. Write a class by implementing interface runnable and define the thread by overriding run method. Understood? Create an instance of the runnable object. Then step 3, what you will do? Create a thread by passing the runnable object to the constructor of thread class. Start the thread by calling start method. That's it. 4 steps. 1 step will come extra. That's it. Now yes, we discussed this question. Which is a better way of creating a thread? Okay, by extending class thread or implementing interface runnable. Okay, so it is not good to write a thread by extending class thread instance, because see, these are the 3 points which I told you. If you extend class thread, you will inherit all the superclass functionality into your subclass, which becomes override for your subclass. Also your class cannot extend what? Another class. And according to OOPS, you are tightly coupling 2 things. OOPS tells always separate the things, either by what is a relation, has a relation, something like that it tells. Understood? So you are tightly coupling. That should not happen. So it is good to write a thread by implementing what? Interface, because you can extend another class, and also you are decoupling both the thread with business logic, which is a very good design. And we will discuss about all these questions tomorrow. Can I overload run method? If I overload run, what will happen? All that we will discuss tomorrow. Clear? In the next session we will discuss. Okay, that's it.